Hey everyone, it's Justin again. Today, we'll learn how to find the x and y-intercepts of rational functions using the functions equation. By the end of this lesson, you should be able to identify x and y-intercepts of a rational function from its equation. First, we'll define x-intercept and y-intercept and see what they look like on rational graphs. We'll learn how to find the intercepts from the function's equation. Then, we'll complete an additional example. So, how would you define an x-intercept? Can you find the x-intercepts on this graph? Hopefully you're thinking that you'd have to look at the x-axis and see where the graph crosses it. We have two x-intercepts for this function. They're probably at -5 and 1, or close to it, but we won't really know without looking at the equation for this function. So far, we're just making an educated guess. The most important part of this to remember for today's lesson is that the y value of both of these is 0. This will be useful to help us find the x-intercept in an equation so we don't have to guess. And what about the y-intercept? There can only be one y-intercept because otherwise the graph would fail the vertical line test and we wouldn't have a function anymore. But where is the y-intercept and how do we find it? Well, this time we're looking for where the graph crosses the y-axis, and that point is somewhere between 0 and -1, but again, we don't know exactly where it is without the equation here. We can guess that maybe it's at -0.3 or so. The most important thing to remember for this is that x is 0. That fact is going to help us find the exact y-intercept in an equation, so we don't have to guess. So let's keep these two most important definitions in mind so we can find the intercept when we're given an equation for a rational function. Now, here's the equation for the graph we were just looking at. Let's find out what we really get for the intercepts and see if we had good guesses. Remember that we said the x-intercepts are when y is 0? Well, if y is 0 here, it must be because we have 0 over something. That means the numerator must equal 0, but the denominator doesn't equal 0. To figure out what would make the numerator equal 0 but not the denominator, we have to factor. Pause the video here and factor the numerator and denominator. Now that we have our factored form, we can figure out what makes the numerator 0, but not the denominator. Remember from our discontinuities lesson that if the factor was in the numerator and denominator, there would actually be a hole in the graph. But here, neither x plus 5 or x minus 1 are in both the numerator and denominator, so we'll be using both of these factors. When setting our factors in the numerator equal to 0, we see that -5 and +1 would make the numerator equal 0, but not the denominator. Therefore, these are our x-intercepts. And actually, this is exactly what we guessed that they were when looking at the graph. Let's add a little reminder to our list here to help us remember what we just did. Let's say that we calculate the x-intercepts using factors that are in the numerator that aren't also in the denominator. Now, let's find the y-intercepts. We know that the y-intercept occurs when x is 0, so for finding the y-intercept, it's actually easier to use the unfactored form of the function. So let's think about what would happen to this if x is 0. What do you think this function would look like if we plug in 0 for x? Well, all of these terms would become 0, leaving us with -5 in the numerator and 21 in the denominator. And actually, that is our y-intercept, -5 over 21. We were pretty close when we guessed -0.3, but an exact answer is always way better. Let's add something to our list to help us remember what we did here. We can say, to calculate, cancel x terms in the unfactored form. That can help us remember how to find the y-intercept. Now that we know how to find the x and y-intercepts, let's do a practice problem. Here's our example problem for today. Try this on your own and see if you can get it right before I explain it. Pause the video now and try to find the x and y-intercepts for this function. Okay, let's see how you did. I like to start by finding the x-intercepts, so the factored form will be the most useful here. I see two factors in the numerator and two potential x-intercepts of positive 4 and negative 7. But there's a problem with one of these potential x-intercepts. You see what the problem is? Positive 4 is actually a hole in the graph because that factor is also in the denominator. The graph doesn't intercept the x-axis if there is a hole where their point should be. Therefore, we really only have one x-intercept this time, and it's at negative 7. So the point is negative 7, 0. Let's move on to the y-intercept. For the y-intercept, we want x to be 0. Remember that the unfactored form will be the most useful here because this helps us see what's left over when x is set to 0. All of these terms would become 0, and we would be left with negative 56 divided by negative 4, which is 14. So 0, 14 is our y-intercept. And now we have both parts of our answer. Now we know how to find the y-intercept from the unfactored form of a rational function, and how to find the x-intercept, or x-intercepts, plural, if there's more than one, from the factored form. In the next lesson, we get to use this knowledge, and the other knowledge we've acquired from this unit, to sketch the graphs of rational functions, all from using the equation. See you then!